stop starting it late because I'm waiting for more people to get here. People get here earlier.
No prize in the mail for you.
Okay, well, good morning, everyone. So, welcome to class. Glad that a few of you can make it. Something going around these days. Actually going to post a webcam video today. I should probably just keep doing that until everybody's done being sick, but the odds of me actually remembering every day are pretty low. Plus, the videos are kind of horrible, and so I feel like, well, I'm going to go watch the video, and a little fuzzy. Anyway, is that?
That's the 26th.
26? Oh, yeah, you're right. That is the wrong day. Well, we won't talk about the 26th. We'll talk about what today actually is, which is like the 28th or something.
Yeah.
Maybe I didn't actually post the notes. That happens sometimes. There's the notes, October 28th. Okay, now we have October 28 notes. There we go. So I'm going to talk about homework 10 real quick. Homeworks have been ticking along pretty fast. Can't believe we're up to 10 already. Homework 9 actually seemed to go pretty well. The main question I got was actually about the whole sensors things and columns and that kind of stuff. And if you run sensors, it gives you something like this. This is on my computer in my office, so it's got a few less cores. But you can get all the core parts this way or whatever. And then you can run it into cut, field, say 2, and go for delimiter of plus. Sure, there you go. Other side, cut, F. Let's go for field 1, delimiter, opening, parenthesis, and you get that side, and then column, and there you go. So something like that, yeah.
Is sensors built into the Linux distribution?
No, you have to install it, and so it makes. Oh, this one just has net drivers in it. You usually do have to install it. I think it's under sensors or something. That's pretty common now. Usually you find it in computers. The thing you usually found wrong with it is nobody's actually bothered to set it up and get it ready to use. And so like on this computer here, we don't have any sensors that are actually being read from. Okay. And actually, you notice it gave us this hint here. So if you want to scan for them, totally safe, sure, go ahead. Are these safe? I don't know, I didn't say. Normally safe, sure, why not? I always learn something. Yeah, why not? Good. Yeah, I'll scan that too. And so, yeah, why not? Okay. No sensors are detected. Your system has no sensor, that's unlikely. And maybe they're connected to this. Well, actually, it's a pretty old machine here. I haven't seen any without sensors in a good long time now. Usually they all have sensors. That's possible. It's just like a low-end machine from like 8 years ago. This is a high-end machine from like 8 years ago. It's also still pretty long, pretty old. We got all kinds of things. You can see fan RPMs. I don't know. Oh well. Anyway, yeah, sensors is on there. Sensors detect. We'll go try and find them. And it's possible there's unsupported sensors on these machines in here. Maybe they just don't really have any that are accessible from software like that. They definitely have a sensor in the CPU that will shut down the processor if something bad happens, like somebody throws a towel over the machine. They started including these pretty far back. But before that, there was no sensor for overheating. A friend of mine was into water cooling. I used to be into water cooling too. And so what he had is, like his computer, and computers are kind of ugly square boxes, and had some kind of hose and then another hose, and they went to a little block here that was on the back of his CPU. And the CPUs are not very big. It was just sitting right there, and so he had some kind of pump. Well, his pump stopped pumping water for some reason. He wasn't sure why. And so the CPU got hotter and hotter and hotter until it melted. He said the whole room smelled bad. Anyway, so that was the old days. But for about 15 years or so, it had some kind of safety sensor. I remember reading one article where the magazine authors, apparently they had too many CPUs. They were testing to see if the shutdown sensor could catch it fast enough if you put the CPU at full load and then took the heatsink off. And it sometimes did. But these days they'll actually scale the frequency down. And I don't think this one actually does that. But if you have a new one, like your laptop or something, the sign that is full of dog hair isn't random crashes anymore. It's that it runs slow because it's running the CPU slow, so it doesn't overheat. Oh, it's all a tangent. Yeah. Oh yeah, that was I'll produce some questions. Crypto didn't really have maybe a couple. Crypto, there's all these different algorithms. And if you look at names, some of them are actually redundant because there's different implementations of them that you might want in different circumstances. Oh, anyway, AES, Advanced Encryption Standard, that's kind of the latest and greatest on the encryption front. Still trusted for like top secret documents and that kind of thing. Other things you might recognize in here, MD5 and SHA-1 are both hashes. So both of them take some kind of text, give you some kind of value that's calculated from the text. These things here, this is like CBC AES or CPR AES, whatever. These are different ways you can run a cipher, ECB. So like CBC here is cipher block chaining, I think. ECB is electronic code book. Anyway, so when you're running a cipher, the usual way to do it is you break your text into pieces. And so you take some piece here, and I don't know, it gives you something, and you encrypt it, and run it through your key. That's a bad rendering of K. It's an encrypted K. How's that? Okay, and you get out some kind of thing it encrypted to. It doesn't matter what. But then next time, maybe you got some other letter here, and you decide to run it through this letter instead of running it through the key. Use that as the key in the algorithm. Then you'd have differences all the way down here, and you can't break this one without breaking that one, and so on all the way back. But there's a few different operating modes that do that kind of thing, and so that's part of what we're seeing with all the other stuff that have AES in them. Yeah, I don't talk about the rest of that stuff. Notably absent from this list, if you were in CS 101 the other day, is RSA. RSA is definitely used on Linux, but doesn't appear to have a kernel module here, so that's fine. Because you can run a cipher in user space too. It doesn't have to be in a kernel module. The kernel module provides a consistent implementation. It's done off in the operating system, and then the user library doesn't have to worry about if they do it right or any of that kind of thing. But you shouldn't take the absence of RSA here. I mean, Linux computers don't use the thing all the time. In fact, I am probably using an RSA key to log into it. Well, not that run. Okay, about to use an RSA key. No password. The reason is I have a public key here, rsa.pub, and this is RSA public key. The private key is stored on Nimrod, and they can work out a scheme here where a software figures out if Nimrod has the private key or not, and if it does, then it's allowed to log in. And so if I went in here and removed the ID RSA there, which is the private key, then I couldn't SSH into iSoptra without a password anymore. iSoptra would just say, no, you don't want to use a password. Oh yeah, so I think that's, yeah, that's about it. Any questions on this? Awesome, good? Okay, cool. Okay, so let's see, homework 10. Homework 10 actually requires you to write a script, which I think is going to be really fun. And so your script, you run it like this. You say like, running on homework 10, and you give it a parameter there, which is the question that it should answer. So in terms of setting this sort of thing up, if we wanted to make well, it's not going to be very interesting here. Okay, I think I actually have a homework 10 sitting around, so just get rid of it. Okay, suppose I'm making this homework 10 here. It's not user bin. I make a bash script. You don't have to. You can use bin.sh if you want to. But I'm going to use bash just because. Okay, so I have our parameter is $1, remember? Parameters start there. So if $1 is equal to 1, using the bracket program here, then, okay, we're going to do something. Phi ends our if. So what we wanted to do, I don't remember what the question was. Echo, put a command here that actually is the question. Okay, and we can do like elif bracket 1 is equal to 2, argument 1 is equal to 2, then echo is plus 2. Okay, and so on and so forth. Syntax error, what did you run? That's good. That's good. That's missing a space. Any others? $1. Do you remember the parameter? 410, 1, 2, doesn't make any difference. It says line 8. 8. Backing it up here. We'll go ahead and do a test. Pound means it's not part of my program. Okay. So it's definitely coming from the LF here. I'm looking for the difference.
Do you have to put a VIN after LF or no?
I don't think so. Let's try. Yes. Okay. So. I'll copy that to the course examples. CS, what is it, 228 we're in? Okay, so now if you go to the website here and examples and homework 10, which is right there, you take a look at that, far right, feel free. Okay, so that's homework 10, should be awesome. Hope everybody's looking forward to it. We'll do the same kind of thing in Python next time. But I think we're going to use actual command line arguments in Python, like flags, you know, like dash whatever. It'll be more fun. Because there's actually a great output or argument processing library that I want to introduce pretty much as soon as we start talking about Python scripts, because it's really handy. Okay, so before this, we talked about how to do stuff in Bash, like ifs and whiles and fors and brackets and functions and alias. Just kind of mentioned those ones in passing. So you can practice them, and that'll be great. But Python is also pretty good for scripting stuff on the shell. I suspect that a lot of you use Python 3, and very few of you used Python 2. Does this kind of sound correct?
Yep.
Okay, everybody here is part of the modern world, except for me. I've only really used Python 2. I've taught Python 3 before, but that's it. And so usually when I write something in Python 3, I have a problem, which will no doubt prove amusing, because we're going to use Python 3 to be compatible with CS111. Okay, so both of these are installed on here. And since you're going to be Python 3 users, you got to remember that Python on here is Python 2. And you can say print I with no parentheses, and it will work. If you want Python 3, just say so. You write Python 3, and you'll get Python 3. And it prints out the version up here, so you can tell if you happen to look at the Python version every time you do it. Oddly enough, our Python 2 version is actually newer than our Python 1 version on Isoptera. But, you know, such is life. Okay. Python 2 is still under active development because there's a lot of people like me that have never made the switch. So if we say print hi, it'll tell us to go take a hike. If we use parentheses, then everything is all happy. Okay, so that's where these things are installed. And so when you're writing a script, if you're writing a Python script, I probably have one here somewhere. Maybe they're all in bin. Oh, my random junk I wrote on there. Okay. So, this is my mailing program. It's impossible to see it up there. It says user bin Python. And so when the script is run, it runs using Python 2. And if we run it with Python 3, we'd say Python 3 right here, and then it wouldn't work anymore. Okay. And no, I don't want to write that. Okay. So there you go. Python 2, I bet it's probably more common even for new code. Yeah, probably. I don't think the momentum behind 3 is caught up yet. In fact, when I teach CS111, we sometimes run into trouble because some of the libraries I think are fun to use aren't very well supported under Python 3. And they're well supported under Python 2, so I don't know. It seems like making Python 3 compatible assignments sometimes results in ones that are slightly less entertaining. And I place a high value on entertaining for assignments. I never know from my homework assignments. How many times have you done stuff with the number of users on the system? Anyway, but so Python 2 is yeah, probably more common, but it's not quite compatible. Language switches are pretty rare in the programming world. If you take a C program from 1975 and run it through a modern compiler, it'll compile. If you go the other direction, it might not, because features have been added to the language over the years. But you know, they continue to be forward compatible. And breaking that compatibility is something that's kind of a big event, because then the new programs don't work. And so then you end up with situations like this, where if we look at our, well, it's the versions of everything on Python. If we look at our Python version, we've actually got a newer version of Python 2 here, indicating that now, instead of one standard, there's two, both under active development. And so trying to avoid that situation is usually kind of a priority in language design. So yeah, they broke compatibility here. Anyway, so the Python 3, there are a few different things that are kind of handy in a way. Like I've been talking about this, I mentioned this print thing here. And if I would say Python, and then we say print hi, it works. If we give it parentheses, it still works. But print is a statement in Python 2. Print is a function in Python 3. Statements are like you know, variable declarations, things like that. So print has been deprived of its special status in Python 3. And that can be kind of important, because if you have, for example, an anonymous function, the function of no name, so if we say x equals lambda, we have to set some kind of variable here, we don't have to. Print a equals and a. Okay. It's going to tell me that we cannot do that in Python 2. The reason is, in Python 2, we're not allowed to have a, well, in neither one really, we're not allowed to have a statement inside an anonymous function. Python 3, you notice, accepts the line just fine, because we don't have a statement inside an anonymous function. We have a call to the print function inside an anonymous function. And we can call a print function, that's fine. And so now we've got this function x, and you know, you can run x to get a 5 or you know, 10 or whatever. And what x is, you know, x is a function like that. And if we want to name it something else, you know, we can be like, okay, instead of that, it's called z. Z is x, and x is 5. Okay, x is 5. Z is a function. Z9. Oh, there we go. We can run it. We can make a function that takes that function. Yep. Take run function with 42. And it takes a function. It's called fun. Okay. So this one runs our function on 42. I forgot my indentation there. That should be fine. 42. Okay, what is it? Z. There we go. If we give it x now, remember x is like a number now. X is like 5 or something. You know, that's not going to work. Okay, that's kind of a tangent. It's called a first-class function, when you can take your function and pass it as a parameter to another function, or return it from a function, or that kind of thing. And you can do all that stuff in Python if you like to. And in Python 2, there was this kind of problem with the whole first-class function paradigm with print being a statement, and so it's fixed in Python 3. Part of the point in talking about that is this is not a difference that you're probably going to care about for this class, or like most other situations in life. So there's the difference here isn't that big. Most of the time, Python 3 code will run in Python 2. So in Python 3, prints a function. There's two types of string. That's the main one that gets people moving back and forth. Most of the time, Python 2 code will run in Python 3 if the whole print thing is handled. That's the most common one, I think. And then these strings, these byte strings. Here's the thing about the strings. maybe we can find a Unicode string somewhere. Okay, so you have Unicode characters. And there's a lot more characters in Unicode than there are in ASCII character, in American Standard Character, whatever, ASCII. I think I talked about ASCII last time in Unicode. Oh yeah, in the EVIL script, the mimic script. So I'll talk about it again. Python 3 has handling integrated for UTF-8 Unicode. And so that's good. But it does mean that you got two kinds of strings in Python 3, and they're not the same, and the differences can cause problems. Okay, so yeah, these break compatibility, and so there's lots of people that have a bunch of Python 2 code that haven't wanted to port it over to Python 3, and haven't really bothered to learn Python 3, so that's kind of holding back its momentum a little bit. Okay, so looking at Python versus Bash a little bit. Well, Bash is certainly older. But the main difference here is Bash is really kind of primarily an interactive use kind of program. You can write a Bash script that does about anything. And here, I'll show you one I used the other day. It's called MKUSB. Okay, I was putting some Linux distributions onto a USB drive, and I was using this thing called MKUSB. Where's the Knox version? And so this is a Bash script. And it starts up here. There's a list of edits and things. That's kind of cool to put on there. And it sets a bunch of variables. And basically what it does is take an ISO image like you burn onto a CD, and it puts it onto a USB drive, so the USB drive's bootable. So then you take your USB drive after the strip's done, and you stick it into the front of some computer, and you turn on a computer, and you can boot up an operating system that's on the USB drive, which is kind of handy. But anyway, so this is a Bash script that goes through and will accomplish that task. And most of the components here, I mean, this should be kind of readable. Like there you got an if statement using a bracket. If the variable CNT1 is greater than or equal to variable CNT2, then you set count to, and so on and so forth. I didn't talk about that for syntax. We use it for what and what kind of syntax, like Python. There's a bash function. Anyway, so I just kind of go on and on and on. There's one thing I noticed in here a lot of that we never did mention, and I feel like I should now. You got this, so you got which apt-get, and we're redirecting the output to dev null, but then we're redirecting the error, standard error, to file descriptor 1, standard output. And the reason we do that is because we want to print out errors, and so we're going to send them to standard output, and then the user can use grep on them or whatever they like, but we're going to get rid of the regular output by sending it to dev null. Anyway, random trick of the day. Okay, and incidentally, this function find installer, the script is supposed to run on multiple distributions and of Linux, and so apt-get is used on Debian, Ubuntu, everything derived from Debian. Yum is used on Red Hat, Fedora, any of the Fedora derivatives, so on. So it checks to see which package manager is around. Okay, so you can definitely write like programs in Bash if you want to. Python is kind of intended primarily as a programming language, but you can definitely use it in an interactive sense too. Let's start IPython 3. I think I got it on here. Okay. Stands for Interactive Python 3. And so we got Python available here. And so if we do something that you do in Python, print hi, it will do it. We also have some commands available like ls or whatever. And we can run commands that are not really part of anything. So if we want to run who, for example, we have to do an exclamation before it, and then it'll run who like it was running it in Bash. And so you can kind of integrate these things together. And in fact, if you want to, you can take some variable and put the output from who into it. And then x, x not w, is actually going to be a list of lines. And so in Python, this starts a list, this ends a list, and so you've got a list of lines here. And you can go through them if you want. You can say for line in X, we want to print, have to use this, line from position 0 up through 10. There we go. There's line at position 0 through 10 for each of the lines. So they're kind of merged together. And you can use them both at once, which is kind of funny, but it works. Yeah, let's go somewhere else. Is that Python 3 on here? No. I'll go ahead and get this thing on here. So then if you decide to use it on here, it is there. Okay, so you can use it interactively if you want to, and that will be just fine. Python 3. There we go. We're back. Okay, there's this command called this get output that you can import, and this gets output from running some command, and gives it to you as a string, which is kind of a mess here. You probably won't use that much if you decide to use IPython for something. So you can change your shell to IPython. That'll probably be fine. Okay, we'll get out of IPython. Okay, so the quick switch guide here is you can use system and get output in Python to run bash commands. So if we have some kind of script in bash, it's like we made a bash script the other day, didn't we? I feel like we did. Yes, 228. Okay. I might have to put an SH on all of them. Okay, I'm not sure what exactly happened there. But we got a bunch of scripts here available. Primes to X. Hey, there we go. There was a, yeah, it's kind of a more complicated one. Something is wrong with my terminal here. Okay, all the prime stuff was stuff we did last time. And run prime. Should convert run prime to a Python script. So I'm going to copy run prime to run prime.py. Oh. Okay, so I'm going to run in Python. So Python, we can't have this style if statement. That doesn't work. But we're going to need get output and get status here. I forgot to mention get status. Is it from subprocess? Actually, system may work too. I should show you what these things do first before I put them in here. Python 3, from subprocess, import, get output. Okay, system, oh, it's OS. Okay, system runs stuff. And you can see it ran, and there was our output from it, like normal with who. So if we run like false, we're going to get a value back from it, which is the exit status. And this just kind of comes out as the last thing here, just prints it out. Okay, let's go ahead and try and capture what comes back from it. Okay, X is a 0. And this will happen, if we run false here, it should be like 256. So whatever came back from that command, like whatever the ending status was, appears here. So if we wanted to run this on prime and give it something like 5, we're going to get a 0. Okay, and if we give it like something that's not prime, we'll get 256. I thought it returned 1. Anyway, I wonder if we're having some kind of Indian issue. Oh well, returns a non-zero. That's close enough. Okay, get output is different. Get output, instead of giving you the status, it gives you whatever was printed out by the program. And see, prime doesn't print anything out. And so what we got for our variable x there was nothing. If we give it something that does print something out, we're going to get whatever printed out. So use system if you want to get the result of the command and just let the output go onto the terminal. And you use get output if you wanted to get whatever would be printed out. And there we go. Okay. So this will run prime.py. We want to use system, and I'll go ahead and import them both. Okay. I forgot to get status was like a Python 2 construct. Okay, so system, prime, and we've got an argument here. We've got to get our argument. Here's our arguments coming in Python. They're in argv. And you get it like that, from sys import argv. And other than that, they work the same. So argv1 is going to be our argument. And so that's kind of the same thing as the prime $1. Okay, but we can't say that because this command is going to be given to bash. This part over here, prime, is a command we want to run. And we have to assemble the rest of it in Python. In Python, you can take two strings and stick them together with plus. So if we go over here and we run Python, if I say fox plus hair, this is fox hair. And you can join together whatever you like. If you say like fox plus 5, it's going to tell you, no, you got a number and a word. You can't put these together. If you provide a quotation mark so that it's like a string, then it just sticks them together. Notice the distinct lack of any kind of space or delimiter of any sort between these two. That's a common source of bugs. Because if we were to leave out this space here, then we'd be trying to run a command. Say the user gave us a 5. We'd be trying to run prime 5 with no space there. And if we do that as all one word, it's going to tell us we don't have any command called prime 5. But if we put a space, it'll work fine. So that space is, putting the space there is actually quite important. Okay, so I have that. In Python, you use a colon and you don't use then. So then you have your, what you want to do here. Okay, last time we said echo $1 is prime. Here we have to use print, and we'll have to use our plus again. argv1 plus is prime. Well, we probably want a space there. It's not like it won't run or anything without the space, but it'll look prettier to have space. And so we definitely want to do that. Okay. In Python, you need a colon after the else, and you put that back there where we'll put that back where it came from. And down here. And it'll take care of that P. And if I can control my computer for a minute, something like this. Okay. So mostly we're just changing where all the pieces go exactly. We have to use system to actually run our prime command, and we have to use Python plus operator to assemble our strings, and we have to use print function there to run this stuff. Let's see if it works. Prime.py. Prime.py. No, it doesn't work because I didn't give it a parameter, like 5. Okay, 5 is wait, not prime. 6 is prime. I think this is like backwards. There we go. No, it's not backwards. Okay, 6 is not prime. 7 is prime. 7,000 is not prime, or whatever that was, 70,000. That might be. Oh, yeah, it is. Well, Okay. So back into this thing. Okay, so that's a Python script that does the same thing. Let's go ahead and convert our others too real quick here. And so I got run prime.py. We got the one that prints out all the primes. Primes to x. Okay. Okay. So this is what it used to do. And what we want to do here, I'll just go ahead and comment this whole thing out here. In both Python and Bash, if you want a line to not become part of your program anymore, just be a comment. You put a pound sign in the beginning. Okay. Python 3. Okay, so I need to run a for loop here. They look a little different in Python. So I start with for, the same as they do in Bash up there. And then we said in. That's actually the same in Python too. But then after that, we use the sequence command to get our range of numbers before. In Python, we want to use range. And range takes a starting point and a comma and an ending point. And we were letting that be our first parameter up there, which is argv1 in Python. We got to go import that stuff. And we'll need system too. Okay, so there we go. We use a colon here. There's actually a problem with that line. And so now the next one down there is if, and we're using system, and what is it? Prime. Not argv1 anymore though, right? N. And there's a problem there too. We'll get that in a minute. And this is also backwards. Then we want to, okay. So starting to fix some of this stuff I left for later. First of all, the problem with argv there and n down here. Argv position 1 is a string, like the text here. Range expects a number, an integer. We have to do the conversion ourselves. It won't do it for us. Might be cool, but it doesn't. Okay, so we call this int function here that takes the argument as a string and gives us an integer. Down here, the other way around. We have an integer and we want a string. So there we go. That's that conversion. Now, lastly, this system thing. So there's a difference in how they interpret this. This whole prime n. Remember, returning a 0 means everything went okay in Bash. And so, if this returns a 0, we're going to go do this thing, because everything was fine. Here in Python, a 0 means false, and anything that's not 0 means true. And so that's why it's going to go backwards on us, and that's why the last one turned out backwards too. And so, we can fix that if we want to. We can say if that one is 0, like if everything went okay, go do that. As it happens in programming languages, a lot of times you end up with this construct where you check to see if something had an error or not. Let me show you something real quick. This is from my CS430 class. Okay, so it's got all these tests. And with each of the tests on here, it lets us know if an error value was returned or not. And so in some cases we want an error, and it says return the correct error. But like for example up here, we want to go ahead and see if we can save a file. And so if we get an error, like if we get something that's not 0, then we go ahead and print out that we got an error. This is a pretty common pattern in Unix programs, and that's fine. But switching between Bash and Python, it can seem a little backwards. And in fact, I made it backwards the first time. So probably that would be an issue. Okay, so that reverses it there though. If that one's 0, go ahead and print n. Here's one reason why people kind of like Python. This whole thing here was 3 lines, and this thing up here was 7. And a lot of times it will make things more compact, like that. Let's try this thing out. Times 2x pi. Oh, we got a list index out of here. Oh, that's because they didn't give us any index. Say 100. There we go. 1,000. Yeah, off we go. Good. Okay, so that works. So that's a couple of cases where we just kind of switch that from one to the other. Okay, so some common use cases. Well, maybe we'll do the pieces here, and we'll get back to that. We'll try that finally. Okay, So pieces that we used in here. I've shown you for loops, and I showed you string concatenation. That's where you stick two strings together. It's called concatenation. And a lot of times you end up wanting to modify strings. We didn't do that in here. And variables, I guess we used it a little bit. They mostly work the same way as Bash, except you never say export. You just go ahead and make them, and off they are. Plus, you don't say $ when you use them in Python. So in Python, instead of saying like, $, whatever, you say like x is 10. And if you want to say parent x, you don't say $x. And if you do, it'll probably have a word with you. Yeah. Okay. So that's those pieces. So yeah, I want to go ahead and do something that might have been hard in Bash, maybe. Couple of words. Okay. So here on last, we got all of this. These are all people who logged in here. And if we want to take out some column, let's say we want to go grab this middle column right here. Maybe that would be a hassle in Bash. I don't know if this is really a big hassle in Bash, because like we could probably use cut and get that thing out of there without too much trouble. But we'll do it in Python anyway. Okay, so here's what I'm interested in. Where are all the locations that people have logged into Isoptera from? Because I'm assuming that they've logged into it far and wide. Now, if we look at last here, last was kind of truncating that field, and it has a lot of stuff about that. For us to display a host name, etc. Display the host name in the last column. That's kind of cool. Put the IP on here. -I puts okay, whatever. Anyway, full user and domain names. That's probably what we want there, -w. Okay, so now you notice we got the full domain name here. And the cost of having this is we messed up all the columns. Part of the reason I wanted to do that is because it would make it a little harder to use cut and that sort of thing. And I want to do something hard in Python. So, now we got these complete ones, MLH310, instructor, whatever. And so, okay, well, places.py. Okay. Okay, so go ahead and use get output here. So that's our basic command to get our output from last so we can start playing with it. Okay. So that's our output from last. And that's just going to be a big jumble, but we want to split this into individual lines. So we can do that. I haven't mentioned split yet. Here's what split does. You have some kind of string or something that makes a string. Doesn't matter which. And at the end of it, you put a period and then split. And so here's an example. Make a string. I have a cat named Kiki. Okay, dot split, and we'll give it a space. Okay, so now it is split into individual words. And you can put whatever you want to in that little split place over there, and it will split it. Yeah?
Actually, the default for split is to split it on space, so you didn't even need to have the...
Default's white space. It's actually more flexible.
Oh.
Yeah,
Okay.
it'll split on like tabs and things too.
Oh.
Yeah.
Well, there you go.
But you're right. If I just did this, it would actually work. Yeah, so there's we can split this thing based on new lines. And then we have a bunch of lines. Okay, so with our bunch of lines, we want to, for line and output from last, go through and get just the field we're after. So we can actually run this directly into print. We'll print there later. Okay, we want to split this thing again. Now, split deals with white space really well. So if we go, let's just go ahead and print this out for the moment. Okay. Yeah. We'll go ahead and print whatever that gives us. Okay. So you can see each of these lines has been split up. You got username where they logged into, and we got the field we want. Now, unlike cut starts counting at 1. So you got field 1, 2, 3, 4. Python lists start at 0, the same as most other programming languages. So you got 0, 1, 2. Okay, well, we were printing out the line.split. Let's go ahead and get item 2. Okay, so in a Python list, I'll pull up Python 3 again here. You can have a list of things. And so, you know, when we said, what did I get? Oh, that's my other cat. Oh, well. It gave us a list like this. Okay. So that's our list. We can put a bracket after this and say which item we want. We have to close it with another bracket, but there we go. So that's the word A apparently. There's 3. Incidentally, you can say you want like 3 to the end, or you want everything up to 3, or you want everything from 2 up through 4, and but not including 4. And it'll do all of this stuff for you. It's called slices. And if you want the last thing, you say -1, and it gives you the last thing. And if you say -2, it gives you the second to last thing.
I think if you use 3 colons and -1 at the end, you can get the reversed.
Like that?
Oh, no, 2 colons, I mean.
Yeah, cool.
Yeah.
So it's got a lot of ways to make stuff out of this list. And I've saved it as our list here, but I didn't have to. We could have just said up here, .split, item 2. And there we go. That's item 2 out of it. Okay, so that's what we want. And we want to print that. Okay. There we go. So it worked for a while. I see a pretty good list here. But we sort of, yeah, like had a problem there at the end. And if we look at that, last eventually has a line that doesn't have enough stuff on it. See what I mean? Okay. A couple ways to deal with that. One, we could say something of the sort, if the line is something we like, then do that. Something of that form will work just fine. And so this would be something like if the length of line.split is greater than 4. And let's go ahead and try that. Unorderable types. Oh, there you go. Just not seeing the right spot. And yeah, there you go. That's not having that problem. The last liner, see that THU at the bottom? If I run last into tail, just to get the last few out, you can see that's the THU right there. And so if we wanted to, we could go ahead and get rid of that right here. Grab that B, let me say something down there, WTMP. And that'll work fine. At that point, we just, let's run the actual script. Finagle the input here so it doesn't happen. We could have just as easily put it into the Python script and said down here something like if that and line split position 1. Well, let's do it more intuitive way. Not WTMP in line. There you go. Take advantage of the natural processing of Python. And that works too. Okay, that's one way. Okay. Okay, way 2. So if I go ahead and grab this whole thing here and bring it down here, here's the second way. Python has a catch-all for if something went wrong, and it's called try. Try that. If it doesn't, accept. Then we don't like it. We don't even have anything we want to do here. Won't take that from us. That's not okay. So we're going to have to put something in there. What's my color? Now, it's not even like that. Print, we had an error. We don't actually want to print that we had an error. We had an error. I mean, it prints out. That's not quite that good either. What would you get rid of it? Nope. Got have it. Okay. What's that?
You can try pass.
Yep. That'll work. Another one would be continue. Continue runs on to the next iteration of the loop. Yep, but you're right. Pass is our solution. I'm going to show the problem leading up to it, but good. Okay, so we're going on there. And so that just basically ignores errors. Okay. Oh, the WTMP. We're going to get rid of the WTMP. Let's just get rid of it up here. Why not? There we go. Okay. Now, I kind of would like to make just unique ones here because there's a lot of duplicates. And, well, we can do that. We can definitely do that. One way to do it, you know, we can just say, okay, well now we've got a Python script that prints all of that stuff out. Sort, unique, and there we go. No more duplicates. That works. But I kind of wanted to just go ahead and do it inside Python. Man, there's a lot of places people logged in from. A lot of them are on campus here, but there's a lot of ones on CableNet or Quest. I can see if Cable One or Quest is more popular than this. Oh, and Roadrunner. Don't worry, Roadrunner. Okay. So, oh, you can see ones where it's got you know, names of computers like Sublab. I don't know. Some of these they look like people's computer. Oh, Nimrod is mine. You can see ones that are actually people's computers on here. It appears that iPhones actually get names. Interesting.
Not
Okay.
necessarily, because sometimes when I log into this and it changes the name of my computer, it'll say iPhone on it.
Oh, okay.
So,
Yeah. Oh, we got ones like Android or something, which I actually didn't see in last. It probably ended up with a 10 dot whatever. Okay. So we want to do this in Python real quick. Not a big deal. Okay. Well, okay, it's a little bit more of a big deal than it should be. So we got this bunch of lines, right? And we're printing them all out. Well, what we have to do is not print the same one twice. And a couple ways to do that. Here's a way to do that. We could I'll show you a couple different ways. We could say we're going to have a list of stuff we printed. And that's blank at first. And then what we'll do is if not line in stuff we printed, we'll go ahead and print it out and we'll add it. Okay, I haven't mentioned about append here. We have an empty list and we want to add something to it. Append adds things to it. And so we can go ahead and do that, and that will probably work. We comment this one out for the moment. Okay. So we don't need sort and unique here. We're going to do it ourselves. So that looks suspiciously similar, some of these things. In fact, I would say it didn't work at all. Let's look at stuff we printed afterwards. Yuck. Oh! We're sticking the whole line in stuff we printed. That's not what we wanted to do. We just wanted to print out the part that we're going to print, right? This part? Okay. Okay. I'll call, you know, the thing to print, I'll just give it a name here. To print equals line split item 2. And then down here, we'll say if our thing to print is that. Change this to. And right here. Okay. That'll probably work better. Okay. I see a list index out of range because it should be inside the try, because it might not work, because we're splitting it and looking for item 2 now, and I think this is going to be good. Okay. I don't see any repeats now. It doesn't sort them the way sort does. It just takes them out and doesn't print them. Okay. That was kind of longish, but it worked. Here's another way. Okay, so we got this these lines here, right, in the output from last. So if we were to take what we want to print out of each of these, then we can, what do I want to say, have a list of all that stuff. Okay, so this is called a Python list comprehension. We'll go ahead and say stuff to print equals everything from output to last, every line in it. For each of these, we want line.split to, or line in output from last. So this is just another way to do the same thing. I mean, this would work fine. Incorporating sort and unique into the whole thing, that would work fine. If we do it this way, then what we're saying is we want the list of each of those things we wanted for each line in the output from our list there. Like go through our list and take the thing we wanted and make a list of all those and then throw all those things and stuff to print. And so then we can go ahead and count this one out here. Okay, oh, actually there's 3. That's not what I wanted. Computers have the ability to duplicate your mistake a lot of times quickly. Okay, so we got our stuff to print. That's what we want to go through now. But here's the thing. This here is just going to be stuff to print. And we got to do a little bit of a condition here. If len of our thing to print greater than, I don't know, 5. It's a blank line. I mean, it's much shorter than 5. It's the thing we're trying to get rid of. So there's our, I guess you don't need that anymore, or that, or that. Oh, and finally, duplicates. You might have noticed those are conspicuously not actually handled anywhere in this entire thing. We will turn this into a set. Okay, see what happens. Whoa, where are we going with this? It's like an infinite loop. I hit Control C. Maybe we better turn it into a set before we start doing a for loop on it. Oh, wait a minute. And look at this. We're printing out the entire thing, not just the line. I'll turn it into a set right here. Okay. So, I don't see any repeats in this. I saw that and I was like, wait a minute. But no, they're different numbers. Okay, let's go look at that again. I'm not convinced that I couldn't have done the set in the first place. So I want to check real quick. Yeah, works fine. It should work fine. Okay, yeah, that's the set. Okay, so that's definitely a shorter way. And so, that would be good. Separate that because these are separate ways. So there's a bunch of ways to do this task. And they all work. And it would work fine to just go through with like cut and unique and set and everything. We just go out with those, look at it too. Okay, so what else do I want to talk about? Okay, we had split there. We used split a lot. That was good. We used string concatenation. We've used variables. We've used a bunch of lists. We did that. That's pretty good. Yeah, why not write everything as a bash script? Yes, you could. Let me show you a couple. Let's go skip to our couple more examples. No, let's not do that. Yeah, let's do that. Because I'm not going to have time to show you an example of writing a script in C. It's compiled, so it's not really a script or whatever. I'll show you a couple of ones that I've written here. Okay, so these are all little Python scripts to do stuff. So here's one for example. This one changes the volume on my computer. So the way it does it is when we run it, it gets output from a mixer, and a mixer stands for ALSA mixer. It also stands for Advanced Linux Sound Architecture. Anyway, so this gets the current volume level for the master volume on the system, and it does some work with grep and such to actually sort out the right output. I don't remember exactly what this looks like. Is A mixer on here? Yeah, so I'm doing A mixer C0. This is a different computer, so it may or may not do the same thing. Yeah, oh, that's good. Okay, so you're getting something like that, simple mixer control master capabilities, etc. And it appears to be all the way up here on the instructor station. Yeah, that's true, the volume is all the way up. We'll go ahead and reduce it just a little bit, just because. Okay, and so if I get out of this and go look at this again, you can see now it's at 87%. I thought I turned it down more than that. I guess I didn't. Anyway, so we get the percent out of there, and playback apparently appears in it on that computer at least. And so argv here. I need to specify up or down. So argv can be either up or it can be, I guess everything other than up is down. And so we already got the volume here. And so we're just going to change the new volume to be what it used to be, +1 or -1. And then at that point we can run get output and set master to whatever our new volume is. And we also unmute it whenever the volume is changed, because I just thought that would be handy. I mean, sometimes, you know, it's muted and you're like, oh, I can't hear it, so you can turn the volume way up. Yeah, so it unmutes it if you change the volume. This is type C. Version RC. So when I push the, it's like key press and like the keypad add and the alt key. This is alt add in Rat Poison terms. It goes ahead and runs vol change and turns up, so they can use the plus and minus buttons in combination with alt change volume. On my laptop, I actually have a volume button, like that has little pictures of speakers with different amounts of waves coming out of them. That runs the same version of the script. Anyway, what else was I supposed to say? Don't need that anymore. Oh yeah, LCCSV. Okay. So on Warrior Web, I can get like a web page that lists all of the people that are taking a class from me, and I like to have a spreadsheet, like a CSV file or whatever, to keep grades in. And so this takes I just take the whole web page, cut and paste it into a file, which is a big mess, and then run this on it, and it straightens it all out and makes a CSV file out of it. Mostly it takes all that junk and cats it and runs it through grep to get rid of some stuff, and it picks out the stuff I actually need from the lines. I use that a lot, it saves me some time. Oh, random Mac. I guess that must be a Python program, yeah. Okay, I don't really use this one very much, but you know, the MAC address on a computer is an identifying bit of information. It comes with your network card. You buy a network card, whether it's soldered onto your motherboard or some other way. And the network card comes with a MAC address, a number that's attached to it forever and ever. And so when you use DHCP to connect to a network, your MAC address is actually used to get your reply. So you say, okay, well, this is my MAC address, and I need an IP address. And the DHCP server says, okay, MAC address such and such, here's your IP address. And usually it records the MAC address just in case. So then later, when somebody talks to the owner of the network and is like, so somebody with IP address such and such was doing something we didn't like on your network, they can look at the log from the DHCP server and say, oh, I gave IP address such and such to MAC address such and such. And that traces everything right back. So anyway, this program generates a random MAC address, and it uses ifconfig to set that for the hardware Ethernet on the computer that this is ran on. Well, you use it for any Ethernet on here, because argv here is the like ETH0 or WLAN 0 or whatever. HW it actually works fine with wireless cards too. So this just generates a random MAC and sets it. Most of the stuff in here is just kind of like Python stuff. And you have to generate with these characters because it's a hexadecimal sequence, and so there's your characters that are available. So we just basically make a string out of random ones of those, and yeah. Okay, battery. I wrote this one at a conference. So I was sitting and listening to this talk at a conference, and I'm trying to remember what it was about. I think it was in the Seattle area, and it was, I think it was about machine learning of some sort. I don't remember. I don't remember what the talk was about anymore. But I was wondering how my laptop battery was doing. And as it happens, ACPI will let you get stuff out of the laptop regarding its battery. And okay, so there's the battery status right now. And that's my battery scripts output. So, I can already see it. See it anyway. ACPI said, battery 0 discharging, whatever. And same thing up here. Oh, actually, it looks like the time remaining has changed. I'm surprised it's discharging, because it was plugged in. Oh, simple. My wife is using the web browser. Okay, anyway, so that's why it's unplugged. And she has no idea we're inside the computer. Okay, so the battery script does that. And tries to figure out how long the battery is going to last based on this number here. And so what they have to do is take the time, and the command date gives you the time. We take the date and we use some stuff with grep to pick out the actual date part of it. Same thing with ACPI. So we're looking for like 2 anythings, colon, 2 anythings, colon, 2 anythings, hours, minutes, seconds. Anyway, and split it up into hours, minutes, and seconds using the colon. And so then we have the number of seconds, the number of minutes, which is also the same thing as the min function in Python. That's why it's blue, but I didn't care. And the hour. And so we can actually add these two. So the amount of time remaining plus the date, the time it currently is when we're going to be out of battery. But we got this little issue here. I mean, if it's currently like 14:52 hours, and the battery is going to last 1 hour and 67 minutes. Let's go for like 25 minutes. And we add this together, we're going to be out of battery at 1577. Which is not really the way normal people do dates. And in fact, you can have more than 100 minutes on there. So the whole thing over here, the minutes are too high. We add the hours and carry the thing and do time arithmetic. And then after that, we can say when we're actually going to be out of power. And then it goes ahead and prints actual date and ACPI stuff. Okay. And something goes wrong with one of these if the laptop's plugged in, and so actually we're lucky it's not. And it says it can't compute the out of power time because if it's plugged in, there's not really enough power time per se. Yeah. Hey, look at it. It's plugged in. Huh. Yeah. It just got plugged in. Since we were talking about that. Okay. I never cease to be amused by computers. Okay. Maybe I didn't want that one closed. I don't remember which one I wanted closed. Okay, so that's the battery there. I'll show you some other examples as days go on here. Questions about Python scripts? I think most of you are in a Python class, CS111.
Mm-hmm.
Yeah, okay. There's the occasional student in a room who's not in a Python class. Or maybe, yeah, anyway. So I hope that made sense. So anyway, that's how you combine Python and Linux, and it should be great. Incidentally, if you ever want to do that kind of thing on Windows, Windows does have a command prompt, and it does do lots of things. And so if you're on your Windows machine and you're like, well, I really want to use get output and do something Linux class-like, yeah, you can do it. It's, I've never done it, but it should work. I've seen people do it. DOS history lesson here. Microsoft used to own an operating system called Xenix, which was actually Unix, like licensed Unix. And they were originally a Xenix vendor. And they eventually sold their Xenix rights to Santa Cruz Operation, SCO. But anyway, so they kind of envisioned DOS as like their home use product, and it was going to eventually increase in capability in order to match Xenix, but without the licensing fees that they actually owed on Xenix. Because they were a licensed Unix vendor, they didn't own it, they just licensed it. And so actually that was the original intent with DOS. And so a lot of the stuff that DOS prompt does is quite Unix-like. And the same thing carries on into Windows. They never did quite finish though. And so there's plenty of things where it would work on Linux and it won't work on a Windows command line. Plus there's some different conventions on them. Slashes go the other way, for example. C:// the slash goes the opposite way of a Linux slash. Anyway, that stuff can drive you nuts. Oh, and the file system is not case sensitive either. Anyway, so it's got a command line. You can do that. Running commands from programs is a perfectly common thing. Any questions, comments? I think I'm done. I don't want to start a new topic in 2 minutes.